Okay, perfect. Thank you so much. So good morning, everyone, or good evening for many of you. Welcome, first of all, to the Q-Chem workshop. My name is Shannon Hauk. I'm a staff scientist at Q-Chem. And first of all, I want to thank all of you for joining us. We're really excited to have you here, and we're very much looking forward to presenting some of the features in Q-Chem and helping you familiarize yourself with Q-Chem as a software package and learn a little bit more about how our software can sort of help you do your molecular chemistry research more efficiently. So first, a little bit about what Q-Chem is. Our mission is basically to develop, distribute, and support innovative and sustainable molecular quantum chemistry software. So what that looks like from a practical standpoint is we 3 times a year have a release of our commercial software. So usually one major release sometime in May or early summer, and then 2 additional bug fix releases throughout the rest of the year. Our team is about 5 staff scientists, and then 1 and a half, if you're counting the person who works part-time, sales team members. So how do we actually do science at Q-Chem with that small of a team and maintain sort of this very large code base? Well, a lot of what our work looks like is actually maintaining the development platform for academic groups who develop their methods and software within our sort of code base and development platform. So we have over 100 active members worldwide who are actively doing development work in Q-Chem, which from a user standpoint means that users actually get access to sort of these cutting edge, peer-reviewed methods because people are doing active research work in Q-Chem as a software. But in addition to that, because our software is really rigorously tested and we have all of these regression tests and sample job tests and things like that before we do every major release, we also have a very stable code base. And so we can ensure that no one pushes anything that causes some catastrophic problems whenever the code is actually published. And we do also offer professional support as well through our sort of customer support email. So I don't want to spend too long here, but you'll be hearing from a lot of Q-Chem team members and also the board, our scientific advisory board of professors as well throughout this workshop. So sort of to orient ourselves within the workshop, our main goal is to sort of get you comfortable using Q-Chem, both the software and also our IQmol, which Andrew will be talking about in a minute, which is our molecule builder visualizer. And then also a couple of different tools within Q-Chem that people find to be useful as they're doing research. So some spectroscopy topics, some of our energy decomposition analysis stuff. And then Martin will be giving a nice sort of overview of Q-Chem and sort of the new features that have either recently been published or will be published soon. In terms of how we're going to structure these hands-on sessions, so the sessions will have lectures first, and then you'll do exercises that we've laid out for you in breakout rooms. So the overall schedule is this. This is also available on the Winter School page if you look there, and also the link to the Google Drive is there as well. So yes. I'll give you a second to sort of look at the workshop schedule, orient yourself, but Andrew will be giving his talk first. So yes, I suppose go ahead and Andrew, if you're ready, I can go ahead and hand it over to you if you would like.
Okay, thanks, Shannon. Okay, is that sharing a slide? Yes.
Yes, so. It is. Yeah.
Okay, so I'm going to, my name's Andrew Gilbert. I'm the primary author of IQmol, and I'll be giving a little bit of an overview, an introduction to using that package, and being able to run Q-Chem calculations using IQmol as well. There are some slides associated with this talk, but I probably won't go through them because I want to make this more of a demonstration. So I'll have the IQmol window up most of the time, but these slides are available in the Google Drive if you want to download those. One thing I did want to just draw your attention to, because I'm not sure what preparation people have done. If you haven't already downloaded IQmol, there's a link in the slides. It's just iqmol.org. And there are binary packages up there for both Windows and Mac. So if you haven't already downloaded, I suggest you try doing that during this talk so that you're ready for the subsequent sessions. Okay, so with that, let me just change screens. Okay, so when you open up IQmol for the first time, this is what you'll see. Basically, there are three sections that we're interested in. There's a toolbar at the top, which has some of the commonly used functions, and we are able to switch between various modes, such as building or manipulation. There's the main builder window or main visualization window, which is in blue. And then on the left-hand side, there's a panel which I call the model view, which basically gives you a detailed view of what the data associated with the system that you're working on contains. Okay, when you start off, you'll start with a clean slate. And what I'm going to do is give you a quick demonstration on how to build a molecule and submit a calculation to Q-Chem. Okay, so the target molecule that we're going to build is aspirin, and we can make use of a library of molecules that are already inside IQmol. So up here you can see there's as part of the toolbar, there's a add fragment button, and if I click that, then I get a choice between functional groups, vector fragment potentials, or what we're going to use here is molecules. And you can see there's a range of systems that are all characterized here. We're going to be interested in the aromatics. We're going to start with anisole here. So if we select that, you can see that the icon or the cursor is a little hammer that's supposed to indicate that we're in the build mode, and so it's an editing mode for the molecule. So now that we've selected anisole, we can just click anywhere in the blue window, and that will bring up a copy of the molecule of interest that we've selected. If we could also create multiple molecules if we wanted to, but in this case, we'll just deal with the one there. Okay, so now if this is going to be our base molecule, and we're going to modify that to create aspirin. And if you're like me, you won't know what aspirin is unless you've got a picture of it in front of me. Fortunately, I do. So the first thing we're going to do is we're going to delete one of these hydrogen atoms. And to do that, we can use the selection mode, which is this little wand or torch, I think. You can see that when a mode is selected, the color of the border of the button changes, just to give a visual indication of what mode you're in. Okay, so now I'm going to select one of the hydrogens. You can see when I select an atom, it gets highlighted in pink. And then I can now delete that using this cross button here, and that's got rid of my hydrogen. If I'd wanted to, I could have selected more than one atom at that point. Right now, the next thing I need to do is convert this other hydrogen into an oxygen, and I can do that by clicking on this build element button here, which, as you can see, brings up a periodic table, and I can select which atom I'm interested in. And again, the the buttons get highlighted to indicate which mode I'm in. So now whenever I click in the builder window, I'm going to be creating an oxygen atom. And in this case, I actually want to turn this hydrogen into an oxygen, so I can just click on that, and that does a little bit of alchemy to make that conversion. Okay, now this, if I want to make a double bond, all I need to do is click on one atom and drag to the atom that I want to increase the bond order. And if I do that, click and release, you can see that that's now a double bond, which is what I'm after. Okay, in addition to adding molecules within the add molecule, add fragment, sorry, selection here, we can also add functional groups. So if we click on that, you can see we have some basic groups here. I can select methyl, and you'll get a visual indication of what I'm adding here in the little picture here. These ones you can see have a yellow dangling bond, and that's just indicating where the functional group's going to be attached. So if I select methyl and click on the hydrogen atom over here in the same way as I changed the oxygen, I've now changed that to a methyl group. And then the last thing I need to do for aspirin is convert one more of my hydrogens into a carboxylic group. So if we grab that one there, make sure we've selected it, and then click there. And I think we have just created a version of aspirin. Okay, so we've done a lot of point and clicking here, but this won't be an ideal structure. So one of the things you can do is you can just clean up the structure by using this minimize energy button. And by clicking on that, what happens there is that IQmol runs a force field calculation just to try and optimize the geometry a little bit. I think if you want, you can select which force field you use. By default, it just uses the universal force field. Okay, so there's our structure there, but we might not be quite happy with it yet because maybe we want to have the planar configuration of it. And as you can see there, it's not quite planar. So what do we do there? Well, what we can do is we can make a selection. I'm going to select these 4 atoms, and I'm going to go up to the build menu, and I'm going to set a geometric constraint. And if I select that, you can see that I'm going to configure the torsion, and I can do one of several things. Actually, I can just set the geometry to that particular angle, or I can actually set up a constraint for a subsequent geometry optimization in Q-Chem. At the moment, we just want to set that to 0 and apply that. Oh, let's go back to the manipulate mode. That's what's that done? That's flattened out that angle there. Still not quite happy with that, but we can also go to the build menu. We can try to symmetrize the molecule. And what that does is if you have a molecule that's very close to a particular point group, it will just slightly adjust the structure to make it actually symmetric. In this case here, we're not close enough to get the CS symmetry. Let's just see if I can adjust the symmetry tolerance here. Okay, so if I relax the tolerance, what that does is give IQmol a little bit more rope to change things with. And I don't know whether you saw that there, but that's now a planar structure. It's just tweaked the geometry, so it's now a planar structure. It did flash up there briefly in the bottom there, but if we wanted to confirm that, we can go into the model view, and you'll see one of the items there is info. And in general, when you want to interact or configure anything within IQmol, you can double click one of these items in the model view. And so if I double click the info item, it will bring up a dialog, which tells me some information about the system that I've just created. And you can see indeed it has detected the planar symmetry there. So CS point group. It also tells me what the number of atoms and electrons and so forth is there. Okay, so that's how we can build a nice symmetric system. Now, what else can we do? Well, another item over here in the model view is surfaces. And if we double click that, it allows us to add one of several surfaces. We can add a van der Waals surface, or what I call a pro-molecule surface, which is sort of a model density. If we select that, we can change the quality of the grid that's going to be used to generate that surface, and just hit calculate.
It doesn't show additional window, I think.
Oh, does it not?
It's also IQmol, so because I think it's just sharing one screen.
Okay. Let me see if I can share the whole screen. Okay, you can see the whole screen now?
We can see the whole screen. Yes, I can see the add surface window now.
Yeah. Oh, okay, sorry about that. Okay, so you're double clicking on the surfaces item, brings up the this additional dialog. As I say, you can change the quality of your surface. We've already calculated that, and once I've calculated the surface, you can see that it appears as an item under the surfaces menu. Again, if you double click the actual surface, you can make changes to the opacity, how it's rendered, or indeed, if we want to put a property on that as well. You'll notice sometimes it goes a little bit flaky there. Just if you redraw the surface, it looks proper again. Okay, so that way you can get sort of an idea of the electrostatic potential, and this is before we've even done anything within Q-Chem. But let's just show you how you can submit a Q-Chem job. So up in the calculation menu bar here, you can see that there's an option called Q-Chem setup. Let's go back here. Okay, so this is the window that will pop up when you try to submit a Q-Chem job. By default, IQmol comes configured to use the server in Pleasanton and Q-Chem headquarters, but you can actually add your own servers there if you want to. But for this workshop, we'll just be using the Q-Chem server, which is there by default. Okay, so let's just reset this. Okay, so here's our geometry that's been copied across from the viewer menu into the dollar molecule section for the Q-Chem input file. And you can see the $rem is also here. And you can see that you can modify the rem settings here by either selecting the options through the controls, or you can edit directly into the right-hand panel there. Okay, and to submit the job, all we do is hit submit, give the molecule a name, and away we go. Okay, so that's submitted a job to the Q-Chem server. We can have a look at the job monitor. And so that's the job that we just submitted there. And what IQmol will do is just keep polling the server to see whether the job's finished or not. And when it has finished, it will come back with this little pop-up to indicate that the files are ready and you can download them. Just give a name for a folder. So we need to create a folder for where the files will be downloaded. There'll be at least 3 files downloaded, which are the input, output, and the checkpoint file. You can see that's now finished. And when we have loaded up the results, there's a little star there indicating that there's some new results there, which we can now have a look at. Okay, so this is our aspirin molecule once again, and you can see now we have some files associated with it. So here we have the 3 files I just mentioned, the output file, the input file, and the checkpoint file. If you want to have a look at any of these files, again, you can just double click the item in the model view, and there you'll have the access to the output file there. Okay, the other thing you can do is now under surfaces. Previously, we only had the sort of model surfaces, the van der Waals and the pro-molecule surfaces available. Now we have the orbitals available because we've computed we have access to the checkpoint file, which has all the molecular orbital information. And so if we double click the canonical orbitals now, we get this dialog here, which gives us a little MO diagram showing us what orbitals are occupied. And it allows us to select some of the orbitals, a range of orbitals if you want. So HOMO -1 to LUMO +1. And then we can calculate those all in one hit. And again, if we go to the canonical orbitals, you can see that we now have access to any of these orbitals. And if we wanted to, we can, again, configure this, change the opacity or the appearance on an individual basis. So the other ones will still have the original configuration there. Okay, so that's very briefly a sort of an outline of how you can draw and submit molecules to the IQmol server. I think at this point, what we'll do is, I believe in the first folder on the Google Drive, there is a document called IQmol Labs, I think. Yes, IQmol Labs. And if you open that, you will see that there are 3 exercises. And we'll break out now and start working on those exercises. So these will be taking us from sort of basic building all the way to actually submitting a frequency calculation. And I guess that's something I haven't explicitly shown here, but I'm hoping that you'll be able to animate and visualize the frequencies in the final exercise as well. All right, so with that, can we head to the breakout rooms?